So hello everyone. So today we are doing a VPNLens showcase. Basically, it's a project I built recently in my summer vacations. So before we go, I just want to say this is going to be a very unscripted and a raw video. I'll actually be walking you through the entire process of how I set up and how exactly you can also set up in your workflows. And if I do Firefox, first of all, let me just show you the GitHub repository. VPNLens. So the project name is VPNLens. Basically, we are comparing two VPNs, WireGuard and Headscale. Headscale itself is based upon Tailscale. It's a self-host version. So before explaining you anything, I just want to go into my server. It's an SSH Atlas. It's a script. So yeah, now I'm in my server. If I do neo fetch, you can see this is my server. It's a Ubuntu VM. And we just clone the repository, git clone, and this is the repository we are cloning, and we go into the VPNLens directory, and here it's fully dockerized. You don't have to configure any single thing. I'll just copy some data, so I don't have to configure it. It's just WireGuard data or some backend databases, and also the environment variables. Let me just copy those. Now we have it. We just run the docker compose file command, docker compose up -d, and it will just pull all the images from my repository or from all the sources, and it will just configure and run everything, unconfigure caddy and all. It will do it all by itself. Basically, it's related to cloud, DevOps and automation. That's the main focus right now, because it's a summer project for my college, and the college asks for a basic report and something like that, and I just want to go a step further and have a portfolio project for myself. So that's why I created VPNLens, and definitely there are some improvements I can do further. Let's just first tell you about what exactly we are doing in here. So basically, we have WireGuard and Headscale, which is based on Tailscale. These are the two VPN sources. What I would say is WireGuard itself is a centralized VPN, and Headscale is a peer-to-peer connection sort of VPN, and it's based on same structure which it's built upon, but there are several differences about the automation, the configurations and something like that. So that I have written in my report and all, but this main project, it focuses on the infrastructure level, the cloud, the automation and everything inside it. So basically, we have two virtual machines, both of them hosted on Oracle Cloud. So basically, these two virtual machines have an encrypted tunnel through SSH, of course, and basically VPN1 have the main control center for both the WireGuard and Headscale. It's always running. It also runs the backend, front end, and also have the documentations. And with what we show it in here, this is all on VPN1. Virtual machine 1, and on the virtual machine 2 we have WireGuard and Tailscale clients. So basically, these do is it connects to the virtual machine 1, and it just simulates some actions and collects some metrics. So basically, we use tools like ping, iperf3. iperf3 servers is also hosted on VM1, and we have htop and all of that stuff. And basically, we calculate the latency, which is basically how much time it takes to transfer one packet. And then there is throughput, which basically is download and upload speeds. Then there is CPU usage. Also, we have RAM usage, like average, minimum, high, and we have packet losses. So basically, what it does is VM1 SSH into the VM2. It connects through an encrypted tunnel through SSH, and then from there there is a script run. This is switch.sh, and there is also a script which is run-benchmark.sh. So the VM1 copies these files, those two files to VM2, and the run benchmark file is ran. So basically, what it does is it simply first it takes a WireGuard client, it connects to the virtual machine 1, and then it gets some metrics and upload on the backend, and then same for the Tailscale. That's it. That's the thing which we are doing to compare some metrics. So basically, from here it goes to the Node.js backend, where it stores everything, and also we have a dashboard which is built by React frontend, and where we just simply showcase what exactly everything is. So this is about the main infrastructure of like actual working, or the architecture of what exactly we are doing. And this is a little bit more complicated sort of explanation, which is simply also same. So now I think my services are also running. Yes, most of them, all of them are. Now we have backend, documentation, WireGuard, the client, host, Headscale, the host, and frontend and the caddy. So basically, before moving any further, I want to show you caddy right now. Caddy is something I explored in this project and I am in love with it. So if I just show you into the configs, caddy, caddy file. So yes, so in here basically this is it. This is the entire configuration. Earlier I was using nginx and it was very hard to configure reverse proxies, automation and things like that. But with caddy it's just one file and it's also dockerized. We can run, like currently if I do docker ps, you can see that caddy itself, where is caddy, yes, caddy itself is running on a docker container and have reverse proxies already built in. We don't have to open any port on the OCI or any cloud interface cloud provider we are using. I don't have to open any port, I don't have to configure any UWF thing. I just simply configure everything on the Cloudflare. I just add this subdomain and I am good to go, and it handles the SSL certificates really well. So that's about it. And if I just show you the code base also, and this is the code base and all of it is dockerized, of course. Let me just show this. Like the front end part is completely different, the documentation is completely different, everything is fully structured and well built in. And we have on the Docker files, we have everything, like we have several containers running and it's fully automated actually. So that's it, I think. And as we can see, the servers are running. So let me just close this. The servers are working in the background. I just SSH'd into it. So now if I just showcase you the actual project which I built, which is VPNLens.summit15gen.com. This is the URL where I have the actual dashboard. I have some data already. There are 13 runs already which I have run in background earlier. So basically this is like the actual interface where the actual data is shown. So now here we have latency, we have packet losses, we have CPU usage, total runs, we have latency graphs, we have throughput graphs, and we have the benchmark histories of like what exactly we have done. And also we have a comparing page which I'll show you in a second. Let me just run the benchmark, add my email summit15gen@gmail.com, and that's it. Benchmarks are started successfully. Now let me just also show you the backend. This is the backend. Yes, so this is the backend. We have also, we already have one output. Yes, we already have. Yes, we have. So there is it. This is the first metric from WireGuard itself. As I said, it's fully automated, so it's actually running on my servers right now. So that's the main thing which I wanted to do, and I have made it working. And also we have WireGuard.vpn.summit15gen.com and also hs.vpn.summit15gen.com. Basically this is for the Headscale. There is nothing into it because Headscale doesn't provide any web UI, just like WireGuard. Like this is the WireGuard UI which is used to configure and everything, but Headscale doesn't provide it. You have to do it manually in the CLI version also. But in there are some things like headplane, there are web Headscale UI and a lot more web interfaces which you can use. But for me, for the use cases, it's fine. WireGuard interfaces is this. And then we also have documentations, docs.vpn.summit15gen.com. So these are documentations which I have generated. Basically these are generated from AI, but the main the structure, the implementation, what I had done, it is actually from there. And this is the email I get. Basically it tells me that we have successfully ran the tests, we have successfully ran the metrics, and now we have the entire dashboard updated. Now if I just check my email, so yes, this is the email I get from benchmark.summit15gen.com. So basically I am using a VPN email sending provider. It was from, I can't remember actually, it was Resend. Yes, it was Resend. it was recent, which is used to send emails, and this is it. This is the type of email you will receive when you run any benchmark. Also, there is a button called View Full Interactive Report. If we click on that, and there you go. This is the metrics we have. So we can just simply check everything, and we can have details of everything, like what ran, Headscale and WireGuard, and which one. Basically a simple web UI report, and we can also print the report from here. And this is about the project itself. This is VPNLens, and definitely there are some improvements I will be going to do. Main goal of this project was to use two VPN providers, WireGuard and Headscale, and just self-host them fully automated on the cloud and make an interface through a dashboard. This was the main idea, and I have got it working. But in future I'm thinking of having Terraform, which can be used to automate the deployment of the infrastructure, and I'm also thinking of having Ansible to configure the entire system. Like currently I'm like, if I just show you in the docs.vpnlens, if I just show in the deployment here right now, this WireGuard and Headscale, I have to manually set up every single thing, but with Ansible I can just simply automate all of it. But yeah, this is it, and I also have the API references if you want to ever check out what exactly the API are doing. Yeah, this is it, I guess. This is a code base, this is VPNLens, and that's it, I guess. Thank you so much for watching.